Hey everyone, so here is the solutions for chapter 1, review 1. So on number 1, if you want to solve this using square roots, let's clean it up first. So we're going to add 9 to both sides, leaving us with 3 times the square root of 2x minus 1 equals, and 6 plus 9 is 15. Okay, finish cleaning it up. Let's divide both sides by 3, which will give us the square root of 2x minus 1 equals 5. And then remember, to get rid of a square root, we're going to square both sides. That'll cancel this out, leaving me with 2x minus 1 equals 25. And then let's continue that over here to solve for x. Let's add 1 to both sides, giving us 2x equals 26. And then divide by 2, giving us x equals 13. Okay, now you guys, because we did square both sides right here in the red, right, we do need to check our answer. So if we put that into here, the 13 into there, so 2 times 13, that's 26. 26 minus 1 is 25. The square root of 25 is 5. 5 times 3 is 15. And 15 minus 9 does equal 6. So this is a correct answer. Okay, so every time you square both sides of an equation, please make sure you check your answer. All right, solve by completing the square. So you guys, on this one, the first part of completing the square, remember, is to move the constant over. But you guys, look, they already did that. This 10 used to be over here, and they moved it over there. So that first step is already done. So we really need to just add our boxes in here, right? So we have x squared plus 4x plus my magic box equals 10 plus my magic box. Now, how do I get the magic box again? I take the middle term, which is the 4, divided by 2, and then I square it. So 4 divided by 2 is 2, and 2 squared is 4. So that is what's going to get added to the magic boxes. Now on the right-hand side, 10 plus 4 is 14. And then on the left-hand side, remember, we want to write this as something squared. So we need to do the big X on that. I need two numbers that multiply to give me 4 and add to make 4. That's 2 and 2. Remember, if you did it right, these two numbers should be the same when you're completing the square. So this is going to factor to x plus 2 times x plus 2, or shorter way, x plus 2 squared. Now to get rid of a square, we're going to take the square root. These are going to cancel out, leaving me with x plus 2 equals, remember, when you take the square root of both sides, a plus or minus pops out. And then we just move the 2 to the other side just by subtracting it. So we're going to get negative 2 plus or minus the square root of 14. Okay? All right, number 3, solve using the quadratic formula. So again, the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Please make sure you have that memorized. There will be one question like this on there where you're forced to do it, okay? So plugging this in, your a is the 3, your b is the 10, your c is the negative 8. So we're going to get x equals negative b, so that would be negative 10, plus or minus the square root of b squared, which is 10 squared, that's 100, minus 4 times your a is 3, and your c is negative 8. Don't forget that negative 8. And then all over 2 times a, which is 2 times 3. Okay, simplifying that, we're going to get negative 10 plus or minus the square root of 100. Now, make sure you get the sign in here first. A negative times a negative is going to be a positive, so let's put that in there. And then you guys, 4 times 3 is 12. 12 times 8 is 96. And then that's all over 2 times 3, which is 6. Okay? Now keep going. This is going to equal negative 10 plus or minus the square root of 100 plus 96 is 196. And then it's all over 6. Now you guys, on your test, I'm not going to make the numbers that big, but remember some of your squares, right? We know that 12 squared is 144. We know that 13 squared is 169. And 14 squared is 196. If you did not know that, you don't have to worry about it. I won't put that on the test, but you could use a calculator on this one if you want to, okay? On the test, it'll be smaller. So the square root of 196 is 14. So this would be negative 10 plus or minus 14 all over 6. And that gives us two answers, right? One of the answers is negative 10 plus 14, not 4. Sorry, let me erase that. Negative 10 plus 14 over 6. And the other answer is negative 10 minus 14 over 6. So on the first one, negative 10 plus 14, that's 4 over 6, which reduces to 2/3. There's one answer. And here, negative 10 minus 14, that's negative 24 over 6, which reduces to negative 4. Guys, hang on one second. I'm going to get myself a Kleenex. Hang on. Thank you. All right. Sorry about that. Okay, number 4. All right, so for this one, I want to get the square root all by itself here. So I'm going to subtract 5 from both sides. So let's go ahead and show that step. So when I subtract 5, the square root of x plus 25 is going to equal, now what is x minus 5? That is just x minus 5, right? Now, to get rid of the square root, I'm going to square both sides. And you guys, here's where people make a really big mistake. You're going to get x plus 25 equals x minus 5 squared. You have to actually write this out. A lot of people fail to write it out twice, and then they mess up, so be careful on that one. Now, when you FOIL it out, you're going to get x plus 25 equals x times x is x squared. Then we have negative 5x minus 5x, which is negative 10x, and I have negative 5 times negative 5, which is positive 25. Now, let's make the left-hand side equal to 0. So let's subtract x from both sides, and then subtract 25 from both sides, leaving me with a big fat 0 on the left and an x squared minus 11x. And that's interesting, the 25's canceled out. Now, a lot of times when people get something like this, they don't know what to do. Remember, you want to factor. And if you don't know how to factor, try GCF. So I can pull out an x out of both of these, leaving me with an x times x minus 11. And then setting each factor equal to 0, I'm going to get x equals 0 for this one and x equals 11 for this one. Now, again, because I squared both sides right there, I need to plug in my answer and make sure that it actually works. So I need to replace these x's with zeros and see what happens, okay? So look, 0 plus 25 is 25. The square root of 25 is 6, and 6 plus 5, remember we replaced the x with 0, that does not equal 0. So x equals 0 is a bad answer. But if you plug in 11, let me do a different color here. If you replace this x with an 11, 11 plus 25 is, wait, did I just do that wrong? I plugged in 0. Okay, sorry, you guys. Let me plug that in one more time. I mean, the 0 is still wrong, but I plugged it in wrong. Sorry. Let's try that one more time. Okay, here we go. If I plug in 0, 0 plus 25 is 25. The square root of 25 is 5. And 5 plus 5 does not equal 0. So this is still wrong, okay? Now plugging in 11. Let's try that one more time. My apologies. If I plug in x equals 11, 11 plus 25 is 36. The square root of 36 is 6. And then 6 plus 5, what does that equal? Well, it's what x is, which is 11. That is a true statement, so x equals 11 is the only good answer there, okay? Sorry about the plugging in there. All right, number 5. Okay, you want to factor. So let's look at the left-hand side. I have 4 terms. So let's try grouping. I can pull out an x squared out of here, leaving me with an x plus 6. I can pull out a negative 16 out of here, leaving me with, again, an x plus 6. Set that equal to 0. Now, if I look at these two terms, they both have an x plus 6 in there. So if I take an x plus 6 out of the first term, that leaves me with x squared. And if I take an x plus 6 out of the second term, that leaves me with a negative 16 equals 0. Okay, just grouping. Now, setting both of these guys equal to 0, this will give me x plus 6 equals 0. If I subtract 6 from both sides, I get x equals negative 6 as one answer. And this one, if I get x squared minus 16 equals 0, if I add 16 to both sides, I get x squared equals 16. Take the square root of both sides, I get x equals plus or minus 4. All right, so 3 answers there, right? Because I have a cube. All right, let's look at number 6. Okay, so this one's awful. Okay, I'm just warning you. All right, this is a happy face. It's a sum of cubes. So I need to rewrite it as something cubed. So it's going to be 2x cubed plus something cubed, which is 5 cubed is 125 equals 0. Okay, now let's go ahead and factor this. So remember, when you have a happy face factoring, you have a little parenthesis and then a really big parenthesis equal to 0. Okay, so my first factor here, if I take away these 3's, is going to be 2x plus 5 And now let's do the happy face on it. So that's your I. You're going to square it. 2x times 2x is 4x squared. Then this sign right here, remember you want to change it to a minus. And do my happy face. 2x times 5 is 10x. And then the last sign is always, always a plus. And 5 squared is 25. Okay, so once you factor that, now we need to set each factor equal to 0. Now the first one is pretty darn easy. We get 2x plus 5 equals 0. So to solve that, we subtract 5, and then we divide by 2. So you're going to get, sorry, I didn't divide that by 2. You're going to get x equals negative 5 over 2. So that one was pretty easy. Now the second one, however, will not factor. No matter what you do to 4x squared minus 10x plus 25, it will never factor if it comes out of a happy face. So you guys, we have to use the quadratic formula on this, which is kind of cool. So let's do it. Ready? This is your A, this is your B, this is your C. So it's going to be x equals negative b. So if b is negative 10, negative b is positive 10, plus or minus the square root of b squared, so negative 10 squared is 100, minus 4 times a is 4 and c is 25. And then that's all over 2 times a, which is 4. All right, let's see what we get. So this is 10 plus or minus the square root of 100. And then you guys look, 25 times 4 is 100. 100 times 4 is 400. So this is minus 400 all over. And then 2 times 4 is 8. If we keep going, we get 10 plus or minus the square root of 100 minus 400 is negative 300 all over 8. And then if we keep going on that, remember we can pull the negative out as an I. Do you guys remember that? So this is going to be 10 plus or minus I square root of, and then how can I break up 300? 300 is 100 times 3, right? And that's all over 8. And the reason I did that, because I know the square root of 100 is actually 10. And so that's just going to attach to that I as a 10i. So now we're going to have, I'm running out of room here, 10 plus or minus 10i rad 3 all over 8. Okay? And look at these numbers, guys. You have a 10, a 10, and an 8. All of those can be divided by 2. So dividing all of those by 2, you're going to get 5 plus or minus 5i rad 3 all over 4. Okay, that was really gross. But look, even though there is something like this on your test, the numbers are not going to be nearly as big. They're going to be a lot more manageable, so you don't have to deal with hundreds, okay? All right, let's look at number 7. All right, so I have 1, 2, 3 terms, no number in front. This is big X. So I have a 60 on the top, negative 17 on the bottom. It's going to be negative 12 and negative 5. Okay, so this will factor to x minus 12 times x minus 5 equals 0. But that's in the perfect world, right? Notice that x times x is not going to give me x to the 4th. So look to the middle term. Whatever the middle term is what both of these x's have to be. And now I fixed my problem, right? So setting each of these guys equal to 0, you're going to get x squared minus 12 equals 0. To solve that, we're going to add 12 to both sides and then take the square root of each. So it's going to give me x equals plus or minus the square root of 12. But you guys, we know that the square root of 12 is really the square root of 4 times 3. And the square root of 4 is 2. So my answer is going to be plus or minus 2 square root of 3. Okay, that's that first one. And then the second one, we have x squared minus 5 equals 0. Add 5 to both sides, give us as x squared equals 5. Take the square root, you get x equals plus or minus the square root of 5. And that one does not break down anymore, so there's all 4 answers. Again, there should have been 4 answers because of this x to the 4th power. Okay? All right, let's move on to number 8. Okay, again, looks a little freaky, but I have 1, 2, 3 terms and no number in front. So again, this is just a big X. Don't let it freak you out. You have a negative 10 on the top, 3 on the bottom. That would be 5 and negative 2. So this would factor to x plus 5 times x minus 2 equals 0. Now again, this is not working because x times x does not equal x. So look to that middle term. That has a square root of x. So both of these x's have to have square roots around it. And now I just fixed my problem. Okay? Set each factor equal to 0. and you're going to have the square root of x plus 5 equals 0. And then if I subtract 5 from both sides, I get square root of x equals negative 5. Now, you guys, remember I told you the square root of x can never equal a negative number, so this is not going to give you any answers. But this one will. If I have square root of x minus 2 equals 0, and I add 2 to both sides, now that's a positive number, so I can go ahead and square it, so x is just going to equal 4. All right? Okay, number 9. Clean it up. So let's add 7 to both sides. So 2x plus 3 in an absolute value equals 17. And remember, absolute value means the distance from the center. So we're going to break this up into 2 equations. 2x plus 3 equals 17. That's moving to the right. And 2x plus 3 equals negative 17. That's moving to the left. And then just solve those 2 equations and you're done. So if you subtract 3 from both sides, you get 2x equals 14. If you divide by 2, you get x equals 7. And the other one, if I subtract 3, I get 2x equals negative 20. And then if I divide by 2, I'm going to get x equals negative 10. Okay, that's number 9. And both of those are your answers. All right, number 10. Oh, fun. Okay, this one, you need to factor this y squared minus 4, right? So let's go ahead and do it. So I have 3 over y minus 2 minus 2y over y squared minus 4 factors to y minus 2 times y plus 2. And then I have equals 5 over y plus 2. Now look, I need to get rid of my denominators because they're kind of gross, okay? So I'm going to find myself a common denominator. If you look, you have here a y minus 2 that repeats, and you also have a y plus 2 that repeats. So one of each of those, my common denominator, or my CD, is going to be y minus 2 times y plus 2. So that is what I'm going to multiply every single term by, okay? So I'm going to multiply this by y minus 2 times y plus 2, this one by y minus 2 times y plus 2, and then this one times y minus 2 y plus 2. And if you do this correctly, all of your denominators should cancel out. So in the first one, your y minus 2 cancels out, leaving me with a 3 times y plus 2. Then I have a minus. All of these guys cancel out. That's nice. So we just have a minus 2y equals, and then the y plus 2's cancel out, leaving me with a 5 times y minus 2. Okay, now at this point, it's just all about solving this equation. So let's distribute. So we get 3y plus 6 minus 2y equals 5y minus 10. Combining some like terms, 3y minus 2y is 1y. So y plus 6 is 5y minus 10. If I add 6 to both sides, I'm going to get y equals, oops, I forgot the y. Y equals 5y. Negative 10 minus 6 is negative 16. And then if I subtract 5y from both sides, 1y minus 5y is negative 4y equals negative 16. And then dividing by negative 4, you're going to get y equals 4. Now, before you get excited and you're like, hey, does that answer work? Make sure it doesn't make a denominator equal to 0. You guys, look, if I plug in y equals 4 into here, or 4 into here, or 4 into here, nowhere will it equal 0. So this is a completely valid answer. Okay? Okay, let's look at number 11. So let's simplify this guy a little bit. If I multiply both sides by 5, these cancel. So you get absolute value of 3v minus 5 equals negative 20. But hey, that can't happen. Absolute can't equal negative, so this is no solution. Okay, look for those. They're kind of easy and cute, right? All right, number 12. Solve the following inequalities. Okay, so I just need to get the x all by itself. So let's distribute. 4 times 5 is 20, minus 4 times 2 is 8x, less than or equal to half of 8 is 4, and then half of negative x, or 1/2 times negative x, is negative x over 2. Okay, so look, I don't like that 2 on the bottom there, so let's get rid of it. I'm going to multiply this by 2 to get rid of the 2, but if you do it to 1, you have to do it to all, okay? So my new equation is 40 minus 16x is less than or equal to 8 minus, and then this cancels out and you just have an x. Okay, now with inequalities, I really like to have my x's on the left-hand side. So I'm going to go ahead and add x to both sides, leaving me with 40 minus 15x is less than or equal to 8. And then I'm going to go ahead and subtract 40 from both sides. and that's negative 15x is less than or equal to 8 minus 40 is negative 32. And then just divide by negative 15. Now, be careful when you're dividing by a negative. Remember, we have to flip the inequality. So that is going to be x is greater than or equal to a negative over negative is a positive. So it's 32 over 15. Kind of a gross little answer, but it is what it is, right? All right, number 13. Okay, let's clean this one up. So I'm going to subtract 3 from both sides. Absolute value of x plus 14 is greater than 14. Okay, now look, this right here is a greater sign, which means my connecting word is an or. You need to have that in there. Without it, you'll get points off, okay? So my two equations are going to be x plus 14 is greater than 14, or x plus 14, remember, flip the sign and make the number negative. So flip the inequality, switch the sign. Now, solving these, if I subtract 14 from both sides, I'm going to get x is greater than 0. Or if I subtract 14 here, I'm going to get x is less than negative 28. Now, this answer is correct, but I want to see this graphed as well, okay? So how would we graph this? So the two numbers I'm interested in are negative 28 and 0. Make sure that you put them in the right order. They both have open circles because these guys do not have equal signs, right? And then if I want to shade these, let's do two different colors here. X is greater than 0, shades to the right. And then x is less than negative 28 is going to shade to the left. Okay, and you guys, this is an or, so it's the union of both of these sets. So the way to write this in interval notation is going to be, this is going to negative infinity. So you'll go negative infinity to negative 28, parenthesis, because that's an open circle, and then you're going to have parenthesis 0 to, this guy's going to infinity, again, a parenthesis, because that's what infinities get. And if I want to join my sets, I'm going to put a union in between. All right, okay, we're almost there. Okay, number 14. How do I get rid of the I on the bottom? Multiply by the conjugate. So I'm going to multiply by 3 plus 2i. Multiply by 3 plus 2i. All right. 2 times 3, foiling here is 6. 2 times 2i is 4i. I times 3 is 3i. And I times 2i is 2i squared. Now on the bottom, because they're conjugates, all you have to do is first and last. 3 times 3 is 9. Negative 2i times 2i is negative 4i squared. Okay, now simplifying a little bit, I can add these guys together. So that'll be 6 plus 7i. And you guys remember, I squared equals negative 1. So I can get rid of this, but then I have to change the sign in front. Same thing with this one. I can get rid of the I squared, but I have to change the sign in front. So what do I have left over? Here I just have a minus 2 left. And on the bottom, I have a 9 plus 4 left. So simplifying these two, 6 minus 2 is 4, so that would be 4 plus 7i all over 9 plus 4 is 13. And I got rid of my I on the bottom. All right, number 15. Okay, this is just a regular FOIL question, right? 5 times negative 7 is negative 35. 5 times 3i is 15i. 8i times negative 7 is negative 56i. And 8i times 3i is positive 24i squared. Okay, kind of big numbers, so let's simplify these. 15 minus 56. Okay, well, I don't want to do that, so let's do it backwards. What's 56 minus 15? That is 41. But because we're subtracting a bigger number, it's going to be negative 41i. And then again, remember the little trick. I squared equals negative 1, so cross the I squared out and change the sign. So it's going to be minus 24. And then combining some like terms, negative 35 minus 24 is negative 59. And then I have a minus 41i. Again, numbers got a little bit big. They won't be so big on your test. All right, let's look at 16. Find the value of the discriminant, then determine how many and what kind of solutions we have. So you guys remember, the discriminant is just the b squared minus 4ac part in the quadratic formula. So this is your a, this is your b, this is your c. Let's plug it in. B squared is negative 7 squared minus 4 times a is 2 and c is 3. Okay, so this would be 49 minus 8 times 3, which is 24, and 49 minus 24 is 25. Okay, now that answers find the value of the discriminant. That's the discriminant, okay? Then it says determine how many and what kind of solutions you have. Well, you look at the discriminant. If you get a positive answer, that means 2 real solutions. If you get 0, that means you have 1 real. It's repeated, right? And if you get a negative answer, that means you have 2 imaginary. So look at the answer I got here. I got 25. 25 is a positive answer, so it's going to be 2 real solutions. Okay? Okay, 17 through 19. Solve the following inequalities using sign line graphs. Okay, this is just what we've been working on the last couple days. So let's first go ahead and factor this. So I need 2 numbers that multiply to give me -3 and add to give me 2. So it's going to be 3 and -1. So this factors to x plus 3 times x minus 1 greater than 0. Let's go ahead and make our sign line graph. So I got to ask myself, what value of x will make this factor equal 0? Well, that would be -3 because -3 plus 3 is 0. And what value of x will make that 0? That would be 1 because 1 minus 1 is 0. Because that's a greater than sign, both of these guys are going to get open circles. Now, let's find our representatives. So a number less than -3 is maybe like -5. -5 plus 3 is a negative number. -5 minus 1 is also a negative number. A negative times a negative is positive, so all of this region is going to be positive. Okay, let's do a different color here, maybe purple. Between -3 and 1, I have a 0. 0 plus 3 is positive. 0 minus 1 is negative. A positive times a negative is a negative. And then last but not least, let's pick something bigger than 1, maybe like 3. Okay, 3 plus 3 is positive. 3 minus 1 is also positive. A positive times a positive is a positive. Now, which one of these regions do I want? Now, 1 second. Okay, I want everything that is greater than 0. What does greater than 0 mean? Greater than 0 means positive. So I want all my positive regions. So I want this region and this region. So those are the ones that I'm going to highlight. Now, writing your answer in interval notation, you're going to go to -infinity here. So that would be -infinity to -3. Parenthesis, and then here you're going from 1 to positive infinity. Again, you join those with a union symbol. Okay, so there's 17. Okay, let's look at number 18. All right, so you guys, notice the left-hand side, all of this is already factored for you. Please do not multiply it out. That would be really sad and a lot of unnecessary work. So I can go straight to my sign line graph. Now, a lot of numbers on this one, okay? So I need to find out what value of x will make that 0. Well, if it's 0, 0 squared is 0, right? What about this guy? What would that have to be to make x minus 4 0? That would have to be 4, because 4 minus 4 is 0. What would this have to be? That would have to be -3. And then you guys, what would this have to be? That would have to be 1. So I have a lot of little intervals here. This is not going to be fun. Okay, so let's look at the very first one. I want to pick something less than -3, so maybe like a -5. And I'm going to plug it in here. -5 squared is positive 25, so that's a positive, okay? -5 minus 4 is -9, so that's a negative. -5 plus 3 is a -2, so that's a negative. And -5 minus 1 is a -6, so that's also a negative. So just count your negatives. You have 3 negatives. If there's an odd number of negatives, the whole thing is going to be negative. Okay? Now doing the same thing here, something between -3 and 0, maybe like a -1. If I plug it into here, -1 squared is still positive. -1 minus 4, that's a negative. -1 plus 3, that's positive. And -1 minus 1, that's negative. Count your negatives. There's 2. That's an even number, so this is going to be positive. Now, something between 0 and 1, let me do a different color. Maybe we can pick like 1/2 here. Okay, 1/2 squared. Well, that's a positive number. 1/2 minus 4, that's negative. 1/2 plus 3, that's positive. and 1/2 minus 1, that is negative. So again here, you guys, I have two negatives. That's an even number, so this is going to be positive. Okay, now let me do another different color like purple. Something between 1 and 4, so maybe like 3. Okay, so if I plug it in, 3 squared is positive. 3 minus 4 is negative. 3 plus 3 is positive. And 3 minus 1 is also positive. Count your negatives. There's only one. That's odd, so this is going to be negative. And then last but not least, oh my gosh, okay, something bigger than 4, maybe like a 5. 5 squared is positive. 5 minus 4 is positive. 5 plus 3 is positive. And 5 minus 1 is also positive. All positives make a positive. Now, one thing I forgot to do, okay, is I forgot to put closed circles on everything. Do you guys see that? Put closed circles on all these little guys. All right, now who do I want? I want everything less than or equal to 0. Things less than 0 are negative. So I want all my negatives highlighted. So where are my negatives? That's this one and this one. So I want all of this plus all of this, okay? Now, this one's a little bit tricky, okay? If you were to write this in interval notation, this is going to negative infinity. So it's negative infinity to -3, parentheses, and a bracket, right? And then this guy right here, that's going to be bracket 1, 4, right? Now, a lot of people go, those are the only negatives, union them together and I'm done, right? But you guys, that's where the intervals are negative. I want to know not only where it's negative, but where it's equal to 0. Remember, they're equal to 0 at these dots. So at -3, here's my -3 that I included. It's also equal to here at 0. So you need to include that 0 in there somewhere. So I need to union a 0, okay? It's equal to 0 at 1. That's included right here in this black bracket. And it's equal to 0 at 4, which is included in this bracket. Okay, you guys, since we didn't do this too much, actually we've never done that before, if you missed that, I wouldn't take any points off because I don't feel like we went over it enough, but if you did get it, I might just give you a bonus point there, okay? All right, let's look at number 19. All right, this guy, left side is already factored, so we can go ahead and do my sine line graph. Make it really big. Okay, what would make this equal to 0? That would be -4. What would make this equal to 0? That would be a 5. And what would make this equal to 0? That would be a 1. Okay, and you guys remember denominators cannot equal 0, so this cannot equal 0. Denominators should always have an open circle on them because we can't have it be 1. But the other two, because it's less than or equal to, can have the closed circles. Okay? So let's pick those representatives. Something less than -4, maybe -5. -5 plus 4 is negative. -5 minus 5 is negative, and -5 minus 1 is negative. 3 negatives make a negative. Okay, something between -4 and 1, maybe like 0. 0 plus 4 is positive. 0 minus 5 is negative. 0 minus 1 is negative. 2 negatives make a positive, and then maybe something between 1 and 5. So maybe you can pick like 3. Okay, 3 plus 4 is positive. 3 minus 5 is negative, and 3 minus 1 is positive. 1 negative makes a negative. And then last but not least, something bigger than 5, so maybe like 7. 7 plus 4 is a positive. 7 minus 5 is a positive. 7 minus 1 is also positive. 3 positives make a positive. And which ones do I want? I want the ones less than 0, so I want the negatives. Okay, so let's highlight all our negatives. It's going to be this one, so all of this. And it's going to be this one right here, so all of that. Okay, so how would I write that in interval notation? This is going to negative infinity, so I'd have negative infinity to -4, parenthesis, bracket, right, because that's a closed circle. And then I have open 1 to 5, bracket, because it's a closed circle, union them together, and there you go. All right, so you guys, I believe that's all of review number 2. I hope that helped. Again, if you have any questions, please make sure you ask me tomorrow in class or come in at lunch. All right, have a good night.